Let's discuss how this bilaminar embryonic disc will be getting converted to the trilaminar embryonic disc. Assume this to be an embryo, and which section I will be describing you is the cut section. So you can see if I will be cutting this embryo over here into two halves, and the cut section which appears seems to be like this. So you are having an amniotic cavity on the upper side, the yolk sac over here, and this is the embryonic disc, the epiblast and the hypoblast. The epiblast is having columnar cells, whereas the hypoblast is having cuboidal cells. The epiblast is the layer which is actually responsible for the development of the three germ layers, namely the ectoderm, and mesoderm, and the endoderm. And the first morphological sign of gastrulation is the appearance of a streak that is known as the primitive streak. Now, primitive streak is nothing but the proliferation and movement of epiblast cells on the median plane to form a raised edge known as this primitive streak. And as the cells keep on moving on the median plane, it extends cranially. This thickening gets extended cranially to form a node that is known as the primitive node. Concurrently, a groove happens in the primitive streak, which will be extending to a depression in the primitive node, and that is known as the primitive pit. So shortly after the primitive streak appears, which in this representation is by this blue band, some of the deep cells starts getting separated from the deeper surface and start entering into the region between the epiblast and the hypoblast, and these cells are known as the mesenchymal cells. And these mesenchymal cells are responsible for the formation of the embryonic mesoderm. Moreover, these mesenchymal cells will be migrating cranially to form a process that is known as the notochord. And in this time only, this epiblast will be forming your embryonic ectoderm, and also the cells from the epiblast will be migrating to the hypoblast region and will be displacing this hypoblast region and will be eventually forming the embryonic endoderm. So this is the next model showing the formation of the notochord. Okay, so we are having what? The embryonic ectoderm, the embryonic mesoderm, and the embryonic endoderm. And in front of the primitive node, the mesenchymal cells have been migrated to form a structure that is known as the notochordal process, which later on will be having a lumen, and that will be known as the notochordal canal. The notochordal process will be extending cranially between the ectoderm and the endoderm, and it will be extending till a region that is known as the precaudal plate. So you can see in this model that the notochordal canal has extended till the precaudal plate. Now, precaudal plate is a small circular area of the columnar endodermal cells where the ectoderm and the endoderm is getting found. There is no mesoderm over here. Further cranial to the precaudal plate, there is an area that is known as the cardiogenic area, in which the mesenchymal cells from the primitive streak will be migrating to the cardiogenic area. And over here is the formation of the heart primordium, which begins to develop at the end of the third week.